Hey guys, Michael from Jonard here with one of our latest products, the OTDR 1000 Multifunction Optical Time Domain Reflectometer. Today I'll be showing you the features of this tester and how to use it. So the first thing that you want to do when you have your OTDR 1000 is turn it on. So just hold the power button for a few seconds and it'll start loading up. Alright, when it's done loading, it'll show the main interface screen where you can see the 8 different modules that you can choose from. So the first is the OTDR module, which gives you a line graph view of what the OTDR is seeing when you do OTDR testing. The next is the event map module, which gives you a graphical overview of what the OTDR is seeing and displays the events in a graphical format so that you can get a better understanding of what's going on. The next module is the OPM module. This just stands for optical power meter. It's the same function as our FPM-50A, just built into the OTDR 1000. Same with the VFL module. This is a visual fault locator, just to provide a visible light source to detect any visual faults within a fiber optic cable. Then we have the laser source, which is the same as our FLS-50, which provides a stable light source for power meter readings. Then we have these 2 modules here, which are the length and tracker and RJ45 sequence modules. These are for network cables. So the length and tracker module is a TDR, so it gives you the length of the network cable that you're testing. It also shows any faults within the network cable, such as shorts or crossed wires. It also has a tracker feature in this length and tracker module. So this just provides a tone for you to trace, which you can do with a separate probe, such as our TEP100 or TEP200. So this is just for tracing any of the network cables. Next, we have the RJ45 sequence module. So this just goes into greater detail, showing you crossed wires, mispaired wires, or shorts within your network cable. Lastly, we have the system settings. This is just the system settings for the OTDR 1000, which you could change here. So starting with the top, I'll be showing you all these different modules. This first module is the OTDR module. Let me open that up. Just to give you an example of an OTDR test, we have a launch cable here, and we also have fiber cable that we're testing. And the first thing that you want to do before you do any sort of fiber testing is you always have to clean your connectors. And you can insert this end of a launch cable into the OTDR port of the OTDR 1000. And then let me just clean this. And I'll connect this side to our cable that we're testing. Before you begin testing, you want to make sure that the settings you have are set up correctly. So, the first setting that we have is the wave. So you can change this from 1310 nanometers to 1550 nanometers. This is because the OTDR module is only for single mode fibers. For now, we're just going to do it in 1310 nanometers. Next, you have the different modes to choose from. First one is the auto test mode. So the auto test mode is where the OTDR 1000 calculates the length of the fiber cable being tested and adjusts the range and pulse settings to be optimized for the cable that's testing. There's also the real test mode. So this is like a live OTDR test, not a live fiber test. The OTDR 1000 will not work on live fibers, but if you are testing a fiber optic cable live using the real test mode, you'll be able to see if a technician down the fiber line is making a fusion splice or a bend in the cable or any sort of event that might occur. The last test that we have that you can choose from is the average test mode. So this lets you manually change the range and the pulse settings. So if the OTDR 1000 encounters, a break in the fiber that's not necessarily at the end of the fiber optic cable, but it thinks it is, you can change the range setting manually here just to make sure that the OTDR is accurately testing the fiber cable that you're testing. For now though, we're going to use the auto test mode. And as you can see, there's still a few more parameters that can be changed, which I'll just go over briefly now. So first is the average time mode. So the averaging time is the amount of time the tester takes to make measurements to calculate the averages of the measurements. So having a longer average time has less noise, which increases the dynamic range and accuracy of the results and allows you to see small events more clearly, such as splices. The average time can be adjusted from 5 seconds to 180 seconds. And the only downside of having a longer average time is that it'll take the OTDR 1000 that much more time to calculate. Next, we have the event loss threshold, which can be used for loss or non-reflective events. So events that are at or above this threshold are recorded in the event table for evaluation. The event loss threshold can be set from 0.01 dB to 9.0 dB. The return loss threshold returns the optical return loss, or ORL, by calculating the total of all light reflected from reflective events plus the total backscatter from the entire length of the fiber being tested. This ORL measurement is sometimes used as a specification for very high-speed systems, as ORL can be a contributor to noise in a transmission link. In most situations, the ORL is set at 40 dB and should not be changed. The end-loss threshold detects the end of the fiber cable being tested. An event that is above the threshold is shown as the end of the fiber. So this end-loss threshold can be set from 0 to 90 dB. Lastly, we have the IOR, or index of refraction. So the IOR calculates the total length of the fiber being tested. Optical length may differ from the length of the fiber jackets in a link due to curves and small variations in the IOR of the fibers. Each fiber type includes a default value specified by the manufacturer. Set the IOR to this value before testing. And the IOR should be between 1 and 2. Now, once we have all of our settings properly set up, you can press the test button to test the fiber. So since our averaging time is 5 seconds, it's just going to take 5 seconds. And it gives you a little snapshot of our results here. If you want to view the results more closely, you can use the zoom function. And if you want to get to the location that you want to, just press the F2 button, which changes where the cursor is. And you can zoom in further if you want to. And once you have this file evaluated, you can save it by pressing the F3 button to save it, and you can give it a file name. If you ever want to load up a file that you've previously saved, you can press the F4 button, and you can go into the date. You can go into the date, and you can load that file again. So if you want a more graphical view of what just happened, you can go to the file, load that file again, and here we can have the events in a graphical format. So as you can see, at 1.01 kilometers, there was a connector, or an adapter and a connector. So that's exactly what happened there. As you can see, that's just our 1 kilometer launch cable connecting with our 10-meter fiber cable that we're testing. And here you are at 1.02 kilometers, which is exactly 10 meters afterwards. We see the end of the fiber cable. So there are no other events within this cable that have occurred, so it looks good. You can also see the same information by pressing the F4 button and going back to the OTDR screen. Here you can see the two events, 2-1 and 2-2. 2-1 is our connector and adapter situation, and 2-2 is the end of the fiber. There are 4 different symbols that could occur. The first is a reflective event, which is shown in 2-1. So that is just when there is a connector or a mechanical splice or a break in the cable. A non-reflective event will look like a step of a stair, and that's usually for bends in the fiber or fusion splices. The OTDR 1000 can also detect splitters, so there's a separate symbol for that as well. When you're done looking at that format, you can press the back button to go back to the event map. And from here you can save the file, or you can rerun the test by changing the settings, or you can load a different file. And that is it for the OTDR part. The next module I'd like to show you is the OPM module, which is just our power meter module. So this can be used with our FLS-50 light source, just to get absolute and relative power measurements of fiber optic cables. So again, before you test anything, just make sure both connectors are clean. And insert this into the power meter port of the OTDR 1000, like so. And plug this end into the light source. And as you can see, the light source is on now, and the power meter part just picked up the power reading. It's also nice because it gives you the relative power and the linear power, and you can set your reference pretty easily just by pressing the reference key. You can also clear the reference just by hitting the Ref 0 button, and you can calibrate it further if you want to, using the calibration button. So the next module we have is the VFL module. This is just a visual fault locator module where the OTDR 1000 just outputs a visual light so that you can detect faults in any fiber cables. There are 3 different modes. First is normal, which just provides a steady laser, like so. There's 1 Hertz mode, which is the slow pulsing mode. There's the 2 Hertz mode, which is the fast pulsing mode. And then close turns it off. You can see, if there's any bend in the fiber cable, yeah, you'll be able to see it like that. And once you're done, just close the laser using the F4 key and press back to exit out of the menu. The next module that we have is the laser source module. So this is the same as our FLS-50, where it provides a light source for single mode fibers. So what you want to do is turn this on, connect one end of the fiber optic cable into the OTDR port and the other into the power meter port. Now once you have the 2 connected, you can press the F1 key to turn on the laser, and it'll provide the light source for the power meter. You can also change the wave to 1550 nanometers, and you could change the mode from a steady laser to 270, 330 Hertz, 1000, and 2 kilohertz. When you're done, close the laser and press back. And now the last 2 functions that we have on the OTDR 1000 are for network cables. First module that we have is the length and tracker module. This module acts like a TDR, but it also can detect faults in the network cable that you're testing. So all you have to do is you plug it in and you press the length button, and this will take about 15 seconds. In the meantime, if you're looking to trace your cable, you can press this F4 button and a tone will be generated so that you can use a probe such as the TEP100, TEP200 to actually trace the network cable. Here we have our results though from the length checker. So as you can see, it has varying lengths of wires in here, and some of the cables are broken, some of the wires are shorted, and one of them is open. So this has a plethora of issues which the OTDR-1000 has detected. Now, if you want to see what a good cable looks like, I'll show you that as well. So in a proper cable, you're not going to have any of those defects where there's wire mismatches, wire crosses, shorts, or any other defects in your Ethernet cable. Here we see that it's 4.3 meters across. It's very consistent, and all the ports are open, so you can immediately tell that this is a good network cable. There's also an RJ45 sequence module, which I'll show you using the bad network cable. And to do this, you plug one end of the network cable here into the OTDR-1000. You also remove the remote from the bottom of the unit and plug it into the other end of your network cable that you're testing. Then simply press the test button, and you will have your results, which show that yes, there are a few shorted cables. Ports 1 and 2 are shorted, ports 4 and 5 are shorted, port 3 is matched with port 1, port 6 is matched with port 2, port 7 is matched with port 4, and port 8 is matched with port 3. So immediately we can tell that this network cable is bad and that it needs to be, the connectors need to be cut off and it needs to be re-terminated. When you're done with that, just press the back button again. And the very last module that we have here is our system settings. So I'll show you real quick. So here you can adjust the auto off setting, so this just automatically powers off the device if it's not in use after a certain amount of time. So you can change this from 10 minutes all the way up to an hour. The default setting is 30 minutes though. You can also change the backlight of this device, just in case you're in a very sunny outdoor area or a very well lit area and you don't need the backlight, you can reduce that to save power. You can also turn on the beep, which, as you can hear, just adds a beep to whenever you move around in the menus of the OTDR-1000. We also have date, time, language settings, which can be adjusted. There's also this cool feature, which is the autosave function for the OTDR module. So here you can set a file name, such as test, for example. And every time you run a test using the OTDR-1000, it'll generate a file that says test 1, test 2, test 3, etc. as you keep saving files for that day. It'll be saved in the individual folders for each day. This way you can save every test that you do. You don't have to manually save every time. It saves a lot of time, and it's a very great feature to have. The last feature that I want to go over is just the USB connection feature. So you want to turn this on when you want to connect the OTDR-1000 to a computer. This just makes sure that the computer reads it as like a flash card, so you can see all the files that you've generated, which will be in .SOR format, and you can move them to your PC to view them in greater detail. The OTDR-1000 also has PC software, no Mac software yet, but that might be coming later. And using the software, you can load the SOR files that you've downloaded from the OTDR-1000 and view them on your computer. And that is it for the OTDR-1000. I hope this was helpful. Thank you very much, and I will see you next time.